In this video, we're going to continue our conversation about the net change as an integral of a rate, but specific to velocity. And we have two different formulas for velocity. First of all, for an object in linear motion, okay, these things can't be moving all over the place. It has to be right to left, front and back. It can't be going all over the place. Okay, this can't be a three-dimensional motion. It has to be two-dimensional. We call the velocity the function v of t. Then the displacement is equivalent to the integral of v of t, whereas the distance traveled is the integral of the absolute value of the v of t. And I want to make sure that you understand the difference between these two before we move on. So here's a little diagram. See if you can follow me here. I made a number line. I'm going to call 0 where home is and 10 something, let's say just 10 miles away. So if you were to travel from home to a store maybe 10 miles away and you return home, your displacement is 0. Okay, the reason is displacement is the distance that you are from where you initially started. Okay, whereas the distance traveled, well, I traveled 10 miles there and 10 miles back. So what was my total distance traveled? That would be 20 miles. So that's the difference, and it's really important to understand that. So here's just a couple quick definitions. So displacement is the distance that you end up being from where you started. The distance traveled is the total distance that you traveled. And that's why when you look in this formula, there's absolute value signs. It's key to total distance. Okay, we have to add up all the positive and negative parts to figure out the total distance traveled. So with that being said, let's take a look at an example. Okay, so our first example says a particle has velocity v of t equals t cubed minus 10t squared plus 24t meters per second. We're going to first compute displacement over the time interval between 0 and 6. And first of all, we have to determine if this is displacement or total distance, because we either have to know if we're using the absolute value signs or not. And with displacement, we don't have to. So to set this function up, we are going to do the integral from 0 to 6, and it's of the velocity function, which is t cubed minus 10t squared plus 24t dt. And we're going to go ahead and find the integral of each of these pieces. So t cubed, we're going to add 1 to the 3. We're going to get t to the 4th and divide by 4, which will give us 1/4 t to the 4th minus, and we're going to add 1 to the square, which will give us 3. So we're going to have 10/3. That's our division of 3, t cubed, and then plus, and now when we add 1 to this t, it's going to give us t to the 2nd. When I divide 24 by 2, what do we get? We should get 12, and then that's going to be t squared. And we're going to close this off and use our vertical bar notation from 0 to 6. So when we plug in 6, 36, and when we plug in 0 to every single one of these, we're just going to be left with 0, which means our final answer is 36, and we have to add a unit onto this. And remember that displacement is kind of like distance, it's just not total distance. So this is in meters. So there's part A. So part B is going to ask us to find the total distance over that same interval. So we can go ahead and set this up first and say that this is going to be the integral from 0 to 6 of the absolute value of our v of t function. And the way to handle absolute value is we have to figure out if this function happens to go negative, because if it does, we are going to have to split this integral up into two separate ones. So we're going to have to find the zeros of our function and see exactly what's happening. So our original function was v of t equals t cubed minus 10t squared plus 24t. So the first thing that I see that I can do to do some finding of my zeros is to factor out a t, since they all have that in common, which is going to leave me with t and then t squared minus 10t plus 24. And within this set of parentheses, we're just going to factor this like normal. So I need factors of 24 that are going to add to give me a 10. And not just any 10, but a negative 10. So we're going to have t here and t here. And let's see, factors of 24 sounds like it's going to be 6 and 4. So minus 6 minus 4. And what we're going to do is figure out where all of these different pieces are equal to 0. So we set the first piece equal to 0, and there's nothing to solve there. In fact, it's at the very beginning of our function, so we're not going to have to worry about this one. The other one, t minus 6, is going to be 0 when t is equal to positive 6. That one's not going to affect us much either because that's actually at the end of our interval. So I have a feeling like this third one is going to be our ticket, and for sure it's going to be. So I have to make sure that I'm going to be able to separate my integral into two pieces with 4 as one of my endpoints. So let me show you how to do that. So we're going to start this by writing this as two separate integrals. The first one being where we start at 0, the very, very last one being where we end at 6. And where these two are going to have to match up is at t equals 4. So that's going to be what's going to separate our two functions. Now, the last piece that we actually have to figure out is which sign goes with each of these intervals. So they could either be plus or minus, but they're only going to be one of those in this particular function. So to draw a quick sketch for you, I'm going to do this up in the right-hand corner. This function looks something like this, okay? The first part of this is all above the x-axis, which means that that integral from 0 to 4 has to be, you guessed it, positive, okay? So what about the second part of it? And the second part of it happened to be below the x-axis, which means that I'm going to have to change that to a minus. Now, once you have those pieces of information, we can just start rolling through with this. Now, we've already discovered what the integral of this function is, so I'm just going to use some general notation here. V of t dt, V of t dt. And for the first part here, we are going to plug in 0 and 4 into the integral function and subtract the 2. I'm going to do this in a quick version here. Okay, so when you compute that, okay, I'm going to go back a page. You're going to plug it in, same thing, into this part, except you're going to plug in 4. You're going to get a number, then plug in 0, which of course is just going to give you 0. That part is going to give you 128 thirds. Okay, we're then going to do minus, and now for this part, the second part, we're going to plug in 6 and 4, subtract the 2, and we're going to get 20 thirds. And forgive me, this is minus and a negative, so this is actually going to be a negative 20 thirds, so we're actually going to add these two together. My apologies. Which means that we're going to end up with a final answer of 148 thirds. So you can actually leave your answer like that, or you can say that it's 49 1/3 meters. So that's actually the total distance that I traveled. And notice that this is different than the answer I got here in part A. My displacement, the distance that I am from where I started, is 36 meters. However, the total distance that I traveled was 49 1/3 meters. So that's the biggest difference between displacement and total distance. And that will actually conclude this tutorial.